All right, this video is going to cover stem and leaf plots, and it's one of the most basic quantitative graphs, and it is an excellent graph. From this point forward, I'm going to refer to it as a stem plot. And in the stem and leaf plot, or the stem plot, data are placed in order from least to greatest. So this is going to be the big task, is getting them in order from least to greatest. You'll remember that in order to calculate the median, we also had to place values in order from least to greatest. Each value of a stem and leaf plot is broken into a stem and leaf component. All right. Now you can do several different types of stem plots, and we're going to specifically look at a back-to-back here in just a moment. Let's just say I had the values 13, 24, 36, 125, and the number 3. Well, if I were to do that, my smallest number is 3, so placing them in order: 3, 13, 24, 36, and 125. All right, so my graph would look something like this. This would be my stem, and this would be my leaf. Well, this first value was a 3. Well, the leaf is always going to be the rightmost value. So for this one, it'll be the 3, here it'll be a 3, here it'll be a 4, 6, and then a 5. Okay. So my stem in this case would be the tens digits, and since there's 0 tens, it'd be a 3. And this would be 13, and this would be 24, this would be 36, and this would be 125. And I would have skipped a ways down to get the 125. So there would have been empty space there. Let's say I happen to have another 14. Well, if I had a 14, that stem happens to be a 1. So this would be a 4 right here. And so basically the stem and leaf plot fills up based on the stem being here, and we only write it once, and the number of times it occurs, or the leaves here. So if we had another 14, we go, oh, we'll get another 4. We had another 14, we'd have another 4. Then if we had a 15, oh, we put a 5. Once again, the 1 acts as the stem for all of that. Okay, so one of the great things about the stem and leaf plot is we can see center, we can see unusual features, we can see shape, we can see spread, we can all of those things. And we actually keep all of our data values, so we don't lose any of our data points. So the reason we don't use it more often is because if we have large data sets, it becomes very difficult, even with a computer. However, on a small data set or a smaller data set, the difficulty is getting them in order from least to greatest, and we can take care of that on the calculator. So first off, I'm going to turn my calculator on. See if I can get more light on this. So I'll pause this for just a moment. Okay, hopefully that's a little better. So I've gone in and entered all my data. And so basically, if you were to look at the backs, so I'm going to look at stat edit. If I go up to top, I put all the back data, all the data through the back into L1, which means if I were to scroll down this L1 column, we go to 81, stat edit, 81, 110, 84, 113, 77, and then we wrap around and we have 75, 87, 100. So all the data has been input for the backs into L1. I also took the time to put all the data into the back, into L2 for the forwards. Well, when you can look at this, you can sit there and go, well, they're clearly not in order, so I need to get these in order. Well, the calculator does it fairly easily. We have a couple buttons to push, but it's not that bad. So on your calculator, you're going to press the second button right there. Here, let me quit out of that screen. The second button. And now I'm looking for the button that says stat. You'll notice, and it's probably hard to see here, that it actually has the word list. And that's what we're looking for. So we're in second, followed by list. And this should have popped up. Arrow 1, place over to the word ops, which stands for operations, and press enter. The reason we could do that is because sort A was selected, and that's sort ascending. Now I want the first column. I want this column, and to do that, I press second, followed by the number 1. And I press enter, and it says it's done. And I'm like, well, what did it do? So I go to stat, edit, press enter again. And sure enough, 75, 77, 81, 82, it looks like they've placed it in all order. So we're going to try that again for a column L2. And we're going to go second, list, arrow over to the word ops, press enter because sort A is selected. But now instead of L1, I'm going to want column 2, so I'm going to press second 2. All right, so when I look at it, everything is now in order from least to greatest for both columns. Well, I'm going to make a back-to-back stem plot. So remember, my leaf is going to be the number furthest to the right. So 5 would be a leaf, 7 would be a stem. So this is what I end up getting. I end up getting a back-to-back stem plot that looks like this: 75, 77, 79. This would read 81, 82, 83, 84, 85. And if you're looking at your calculator, got a lot of shadow here, not a whole lot I can do about that, but it follows the same numbers. We have 75, 77, 79, 75, 77, 79, etc., all the way up to our largest number happens to be 120. So we have a 110, 113, and a 120. That's just for the backs. Okay, and so real quickly, I can sit there and see that I have a shape. I can sit there and go, all right, here's my shape. Now you have to be really careful when we go to describe what that shape is. Everyone sees pretty quickly it's skewed, but which direction? Just take a moment and make a number line of the lowest number and the highest number. Well, my lowest number was a 7. My lowest stem was a 7. My highest stem was a 12. Well, I only had one data value here, and I had a whole bunch of data values here. So this means it's skewed to the right. Again, all I did was put a quick number line. It's like, okay, it's skewed to the right. So we know our shape for this one is skewed to the right. When I fit one to this one, I see it's mound shape. And so I've labeled this with backs, I've labeled it with forwards, and this part right here is my stem. Leaves for the backs and leaves for the forwards. Now, I always need to make a key or a legend. So this says 10 and the number 3 is 103. All right, this first part, I'm going to save you some time on what you need to write because I've written a ton here, but you can skip writing this first part and the second part. I just want to show you what I have. If this was not a back-to-back, if I only had a single description, I would need to describe the backs. Well, the weights for the back are skewed to the right with a median of about 90. And by the way, I could actually go on to stat, calc, one variable statistics. Do that again. Stat, arrow over to calc, one variable statistics. My data list is an L1. And there's everything, and it goes, oh, we end up with a median of about 90. All right. The back have a range of 45. That's going to be the smallest minus the largest. So the range is going to be 120 minus 75. So a range of 45. And it lies within the interval 75 to 120. I probably should have made the comment that there's no gaps or outliers. That way I've addressed unusual. So how did I address center? Because remember, we always have to cuss. I addressed center by saying I talked about the median. Then I addressed shape, about it being skewed to the right. And I discussed spread by saying that they had a range of 45. I could have talked about the interquartile range as well, because that information was given to me, Q1 and Q3, and I could have subtracted those and got in my interquartile range. So that discusses this, the first distribution. The second distribution is the weight for the forwards. And in this case, it's reasonably symmetric and mound shaped. All right. And the weights have a range of about 41 kilograms. They have a median of about 105. And by the way, I can get that again from the calculator, stat calc. Press enter. But now instead of L1, I want column 2. And the median's 105. It does that for us. Of course, we could have actually used the graph to do it. All right. And they have a range of 41, which is going to be 89 and 128. So 128 minus 89 gives me that 41. All right. And this is where it lies. Well, this would be only, I would do this one if I was only describing the backs distribution. If I was only describing the forwards distribution, I'd use this one. But most of the time in AP statistics, we have two distributions, which we have here, and we're required to have a comparison. So this is what they're looking for, is the actual comparison. So the weights of the back are skewed to the right, while that of the forwards is symmetric and mound shape. So now we've addressed shape. The forwards median weight is 105 kilograms and is higher. So I need to use some sort of comparison word. Greater, more than, larger, I used higher, is higher than the 90 median weight of the backs. The backs have a range of 45 kilograms and are more spread out, so more spread than the forwards weight, which is 41 kilograms. Really important that you use comparison words. I used more here. If I swapped the order, it would have been something like less. And by the way, you can use while for comparing shape, but not for comparing numerical values. All right, so that's really important. All right, I'm going to pause this video or stop this one. Thank you.